Greetings, Panthers. It's Dr. Augustine, and I hope you all are doing well today. We're in the middle of Chapter 2 in Tro's book, and there are a lot of definitions in Chapter 2, just defining terms, defining words. And so there's going to be a series of quick videos I'm going to make, which are just definitions of words to help you understand when you read subsequently, what an atom is, what an ion is, what a isotope is, that sort of thing. And I'm going to break them down into sort of groups together. So that should make it easier, and they should be really quick videos to help you understand some of these terms. So the first one I want to distinguish between are atoms and ions. So atoms are the building blocks. An example of some different atoms would be something like carbon or nitrogen, oxygen, etc. And an ion is actually a charged atom. Now, how can this become a charged atom? Like what would make an atom charged? So atoms are going to be neutral, not charged. What is it that makes them charged? Well, if you think about what's inside an atom, we have protons, neutrons, and electrons. I'm just going to write E minus for electrons. Those are the three building blocks of each atom. Those are the subatomic particles. So inside the nucleus are protons and neutrons, and I'll just draw maybe the neutrons squiggled dark and the protons as open circles. Okay, that's inside the nucleus, and I'm drawing them so they're closer. That's not necessarily artistically correct. And then outside of the nucleus are the electrons, and they are in certain orbits. We'll learn more about where the electrons are, but they're not in the nucleus. And I do not even close to have this to scale. If you remember in the last video, we talked about the size of the nucleus compared to the size of an atom. If you picture a football field and you put a marble at the center of the 50-yard line, that's the size of the nucleus, and the football field of the electron cloud. So the electrons have a huge area compared to the nucleus. If I was to draw this correctly, there might be just a teeny tiny dot would be in the middle, would be the nucleus, and then all the rest of it surrounding it with the electrons. Okay, so remember, protons are positively charged, and electrons are negatively charged, and neutrons are neutral. So in order to have a charged atom, we have to have either the protons or the electrons involved somehow, and the neutrons really don't matter. Well, it turns out it's actually the electrons that are involved, and the electrons can either be added to the system or taken away from the system. So we can either have extra electrons in our atom, or we can have not enough electrons compared to the number of protons. So let's suppose we have 7 protons and we have 7 electrons. So if we have 7 protons, I'm just going to draw these like a P plus, I'll call it, and I have 7 electrons, that is going to be a neutral atom. Doesn't matter how many neutrons I have. If I have 7 plus charges and 7 minus charges, they cancel each other out and I have a neutral atom. But I can have a situation where I have, let's say, 7 protons and 6 electrons. So in that case, I'm going to have a positively charged atom. And we call this positively charged atom a cation. I've heard people pronounce it cation. That's not how it's pronounced. It's pronounced cation. And in the flip side, if we have 7 plus charges and let's say 9 electrons, then I'm going to have a net -2 charge, and so this is negatively charged, and we call this an anion. Now I don't know the guy who did this, but this cartoon, you can find this on Blogspot, said cats are good, they're positive, onions are bad, they're negative, anion are bad, they're negative. If that helps you remember cation and anion, that's fine. I don't know if cats are good necessarily, but positively charged atom is called a cation. A negatively charged ion is called an anion. And we're just going to refer to these going forth in the future, that if we have a situation where we have a negative charge, we're just going to call it an anion. Remember, in a given atom, the number of protons do not change. The protons are constant. The only things that are changing are the electrons. We can either have a neutral atom if they're equal. We can have a positively charged if it's cation, which means less electrons than protons, or we can have a negatively charged anion, which means more electrons than protons.